Hi class, I'm going to give you 3 commentaries on different word problems associated with chapter 1. We're going to begin with page 62, problem 24. So this problem, the way I'm going to approach it is by first creating a table with all the given information. It just helps to organize my thoughts and to show me what I know, show me what I don't know. So this is exactly what is given in the problem. We have green peppers that cost $1 per pound, orange peppers which cost $4 per pound. I bought 3 total pounds of peppers and the total cost of all my peppers was $4.50. I want to find out how many green peppers, how many pounds of green peppers I bought and how many pounds of orange peppers I bought. So the first step I do, I need to define a variable at this point. So I'm going to define a variable g for the pounds of green peppers. Now, I could define another variable o for the pounds of orange peppers, but I really want to avoid assigning more variables than I need. And before I assign the variable o to it, I look at my information that I've been given, and I realize that I've been told that I have bought 3 pounds of peppers, and so now I can express my orange peppers in terms of 3 minus g. So I'm going to use this to express it instead of defining a new variable, and this is the trick. That's what makes it possible. So now the cost of green peppers will simply be $1 times g, and then my cost of my orange peppers will be 4 times 3 minus g. So I add up the cost of my green peppers plus the cost of my orange peppers, and I will get $4.50. So this is the setup. This is the equation that we can now solve. I won't really go into depth about how we solve it. It's pretty straightforward. We'll get down to 2.5 pounds of green peppers, and from there we plug that back into this equation for pounds of orange peppers, and we get 1/2 pounds of orange peppers. Okay, next problem. Let's move on to the next problem. This is problem 33 on page 63. Again, I'll just rewrite the problem. It said that the total car rental was $293, and this is exactly what was written in the book. The car cost $180 plus 25 cents for every mile over 150 miles. I put it in quotes because that's what the book said. And so how many miles did I drive? That's the question. So the first thing I do is define a variable x. X is equal to the number of miles driven on vacation. And look at how I wrote it out. I'd like you to write out the definitions of each of your variables just like this. Let x is equal to something. Okay, now that I have that, look what I can do. I can just take the sentence up here that explains the car cost and just translate word by word each portion of this into an equation. So look how I do that. 180, 180. Plus, I turn it into a plus symbol. 25 cents, 25 cents. For every, I put a multiplication sign. So 25 cents for every mile over 150. So I'm going to stop right now, and I want you to think about how you would express miles over 250. You can pause it for a second, and I'll give the answer right now. So you can express it as x minus 150, and that's the trick for this one. So now that we have the total car cost, we know that this equation is equal to $293. That's how much the car rental was. So now we have the equation. I'm going to show how I could solve this. I use fractions. I turn the 0.25 into 1/4. It's a quarter. So I distribute that across my x and 150. I get 1/4 x minus 150 divided by 4. And I take my 180 and I move it to the other side. 293 minus 180. So now the next step I do, I multiply both sides times 4, and notice when I do it, I make sure I'm multiplying the entire right-hand side by 4. And so then I distribute my 4 across the 113. So 113 times 4 is 452. 150 times 150 divided by 4 times 4 is simply 150, and then I can do the math to get 602 miles. Okay, the next problem I'm going to do is page 65. It's one of your homework problems, actually. Problem 30. It's a window washing type of problem. 2 people working, myself working at a rate of 1 window for every 15 minutes, and my sister who can wash a window every 20 minutes. And the question is, how long would it take to wash 12 windows if we worked together? So the first thing I want to talk about is, again, the generic work equation. The generic work equation would look like this. Total work is equal to work of all the individuals. The work of each individual is their rate times the time that they work. So we have, in this generic case, we might have many workers. Worker 1, worker 2, worker 3, ... We have the rate of each worker. They might all work at different rates. We have the time that each worker is working. And in this case, in the generic case, they might work for different amounts of time. Okay, so now we've talked about the generic work equation. Let's look how it applies to this very specific problem. So in this problem, my rate is 1/15th. My sister's rate is 1/20th. Notice how I use kind of convenient lettering mnemonics when I define my variables. So the rate of me, the rate of my sister is what I use so that I can easily understand what the variables mean. So that's the rate. The time, we spend both the same amount of time together. So I don't need to define a T1 and a T2 or a TM and a TS because we're working the same amount of time. So now that I have these variables defined, I can rewrite my work equation specific to this situation, where the total work is the rate which I work times the time, plus the rate that my sister works times the same amount of time. And now in this case, we can now plug in the numbers that we know, where 12 is equal to 1/20th or 1/15th t plus 1/20th t. And if you can get to this point, this is the really key place for the equation. Now, to solve this, this is what I'm going to do. I'm going to use a little trick where I'm going to find the least common multiple of 15 and 20. So I factor them. 15 has factors of 3 and 5. 20 has factors of 4 and 5. And then I circle the ones that will bring me to my least common multiple. I take 3 and 5 and 4, multiply them together to get 60. The reason why I don't multiply by another 5 is because I've already multiplied by 5 here. It's a common factor in both, so I don't need to multiply again by 5. So I multiply both sides times 60, and it very conveniently distributes. 60 divided by 15 is 4. 60 divided by 20 is 3. So now I have a very nice equation here, 4t plus 3t, that I can quite easily add in my head. So I have 7t is equal to 60 times 12. And actually the reason why I did not actually multiply this out, because I know we're working in minutes, and I see 60 minutes here times 12 windows. And I'm thinking to myself, I'll just change the 60 minutes to an hour. So I continue on down. I get to my final answer of 12/7 times 60 minutes, and I just convert that to hours. 12/7 of an hour is how long it takes. And fractions are perfectly good answers.